So, very good morning everyone. My name is Pushpinder Singh and I am Sales and Service Engineer at Advanced Technical Systems Private Limited, Delhi. So today I am going to show the measurements of this LCR meter, that is IET LABS LCR meter model 1920. This is basically your precision LCR meter model 1920. It has an accuracy of 0.1% and measured frequency range up to 1 megahertz. So we have already, as you can see, that we have already kept the instrument on. We have already kept the instrument on here, okay, and we have already connected the cables. So basically, with this LCR meter, we are going to use this cell, dielectric cell. This is basically your powder and paste dielectric cell, and which is used for measurement of capacitance and dielectric constant of powder and paste materials. So first of all, we'll show you the connections. So we have already connected this LCR meter with the cable, which is basically your BST to BNC extender cable, as you can see that. And on the other side, we have connected on the potential side. Basically, this is your load sides. We have connected a density on low current and low potential side, and high potential and high current side we have connected again a T. Okay, and this is basically your dielectric cell that is used for the measurement of, it is used for measuring the capacitance and dielectric constant of powder and paste materials. As you can see that this is basically, there are two electrodes. This is the top electrode and this is your bottom circular electrode. So basically, whatever the material or powder paste you want to measure will keep inside this, and then you need to just use this knob so that it makes a contact between that material, that dielectric material make contact between these two electrodes. We just need to adjust this lower electrode, circular load, so that it may contact with the upper electrode. So now we are going to make the connection. So basically, these are two T connectors, and first of all we will connect as you can see that there are basically two connections. One is the GR874 connection. Here we are going to use this GR874 to BNC connector. Okay, now it is converted into BNC one, and there is one more connection here for lower electrode. This is for the upper electrode connection, and this is for lower electrode connection. For this we are going to use this BNC to banana connector. We'll connect like this. So the higher side will go on the electrode side, top electrode side, and the lower side will go to this BNC side. So this is the setup that we are going to use. So first of all, in order to verify this cell, we have one Teflon standard. This is a Teflon standard that we have, and the dielectric constant value of this is 2.046. So this standard we are going to use to verify the performance of this MC-100 cell Teflon standard. So what we'll do, first of all, we'll take this Teflon standard, okay, and we just insert into this cell. Okay, now we insert it. Now we'll have to, as you can see that there is a space between that Teflon standard and the top electrode. So we'll raise this lower electrode, okay, so that it may contacts with that upper electrode. Okay, Now you can see that it has touched that. Now it is that Teflon cylinder may contain the bottom and the top electrode. Okay, now we will take a measurement. We'll come to the LCR meter. Here you can see that we have already done the settings. If you will see here, we have set the parameter capacitance and dissipation factor for measurement, and the frequency is 1 kilohertz. Okay. So what we will do is that we'll just make the measurement. Okay, so we'll press start. As you can see that it's already set to CP and DF parameter, measurement parameter, at 1 kilohertz. Okay, so the value that is reported is CP is, we will note down this value. Okay, CP value is equal to 2.97 in 10 to the power minus 12 farad. Okay, and dissipation factor value is 0.002557 with Teflon. Okay, now we have noted down this value. Now we will perform, first of all we will press a stop button. Okay, now we perform the same measurements without this Teflon standard in air in order to measure the capacitance of the air. So what we will do is that we'll just remove this Teflon standard. Okay, without changing the electrode position. Now you can see that there is no standard. Now we are going to measure the capacitance of air. So we'll press the start button. Okay, and the value is 1.10. Okay, so with air, I'm just noting this value. With air, the capacitance value is 1.1091 into 10 to the power minus 12 farad, and dissipation factor is 0.006535. Okay, so you can see that here that Teflon value, with Teflon the capacitance value is 2.2797 into 10 to the minus 12 farad, and with air the capacitance value 1.1091 10 to the minus 12 farad. So to find out the dielectric constant value, K is equal to C of material, that is Teflon. Okay, Teflon by C of capacitance in air, which is equal to 2.2797 10 to the minus 12 farad divided by 1.1091 10 to the minus 12 farad, which is equal to, we will calculate 2.279 divided by 1.1091, which is equal to 2.054. Okay, and if you look at that specification of the Teflon standard, because the electronic constant value is 2.046 and our value is 2.054, so we are very close. So this is how we can verify that, okay, that our MC-100 dielectric cell is working properly fine, and instead of this, now we can ensure that it is working properly, and now we can use any other powder coated or paste material which we can insert into this in basically electrodes, and then we can measure the dielectric constant with respect to air. So this is how we will do the measurement of this, and thank you for watching this video.